Welcome, everyone! So today we're diving into the latest release of the DocWire SDK. And let me tell you, this is not just some incremental update. We're talking about a significant architectural evolution here, a major overhaul of the SDK's core that's all about building a more powerful and reliable foundation for your application.
You know this quote right here? It just perfectly captures the whole philosophy behind this release. The goal wasn't about adding a bunch of new bells and whistles. No, this is about prioritizing foundational strength, correctness, and predictability. It's about building an SDK that you can truly, genuinely trust for your mission-critical work.
So here's how we're going to break this down. We'll explore this whole overall across 5 key areas. We'll kick things off by looking at what it really means to strengthen the core. Then we'll dive into the modernization with C++20, a whole new paradigm of safety, see how the SDK handles messy, real-world data, and finally we'll wrap it all up with the key takeaway.
All right, let's get into our first point, strengthening the core. And again, this isn't just about a few minor tweaks. We're talking about fundamental architectural changes that are really designed for long-term stability and impact.
Think of it this way. We're not just redecorating the house. We're ripping out the old foundation and reinforcing it with industrial-grade steel. This is a fundamental upgrade, and it's all focused on long-term stability and enterprise-grade resilience. The idea is to make sure the applications you build are secure and absolutely ready for whatever the future throws at them.
So, the first pillar of this big modernization effort is the full-throated adoption of C++20. And you know, a perfect example of this is the brand new API for handling XML, which we're going to look at right now.
For those of you who've been using the SDK for a while, you'll know the old XmlStream API. Well, it's officially a thing of the past. It's been completely removed, and in its place is a modern, expressive, and way safer parsing framework that's built from the ground up around the power of C++20. And this really shows you the performance philosophy behind the new API. It's a single-pass, forward-only reader. So what does that mean? It means it's designed from day one for pure speed and efficiency. It's perfect for streaming and processing massive, complex XML documents without just bogging down your whole system with heavy memory allocations.
With this new API, you, the developer, now have an incredibly expressive and allocation-efficient toolset. You can use components like XML Reader and XML NodeRef and combine them with the awesome power of C++20 ranges and views. This lets you filter and manipulate XML nodes with a level of clarity and safety that, frankly, just wasn't possible before.
Okay, now let's shift gears and look at how this release introduces a completely new level of explicit safety and control. It's really about moving away from that murky, implicit behavior and giving developers the power to enforce correctness right from the design phase.
A really cool new concept here is safety policies. You can now explicitly choose the level of safety you want for your build. The strict policy? That gives you robust, runtime error checking that'll throw exceptions when something goes wrong. Absolutely perfect for development and testing. But then, for your production builds, you can just switch over to the relax policy for maximum, zero overhead performance. It's the best of both worlds.
Gone are the days of ad hoc manual string conversions. Say goodbye to that headache. They've been replaced by a really robust convert framework. By using the new convert.try2 and convert.to APIs, you can perform explicit, type-safe data conversions. This eliminates an entire class of potential runtime errors and, just makes your code so much more reliable.
And this philosophy of correctness, it's everywhere. For example, the new not null wrapper can enforce non-null guarantees at compile time. How great is that? Similarly, all date and time handling has been standardized on the modern std chrono library. The error-prone legacy struct TM is completely gone. Every one of these changes boosts type safety and robustness across the entire SDK.
So, this is the crucial point, right? All this correctness is fantastic, but how does the SDK actually perform when it's faced with the messy, imperfect data that we all have to deal with in the real world?
This is such a critical question for any developer who's processing large batches of documents. In the past, a single corrupt file tucked inside a zip or a PST archive could bring the whole process to a grinding halt. Well, that has now changed. The SDK now introduces what's called partial failure resilience. So instead of a total failure, the parsers for formats like EML, HTML, and PST can now gracefully handle corrupt subitems. They use these message counters to track the individual failures, which allows the process to continue with all the valid items while still reporting on any issues it found. This is a massive improvement for real-world resilience. And it goes beyond just partial failures. Memory management itself has been seriously hardened. By using modern C++ idioms like std_uniquePitter and RAI, which basically guarantees that resources get automatically cleaned up when they're no longer needed, the HTML and PST parsers now ensure exception-safe cleanup. This prevents crashes and resource leaks even when things go wrong.
Okay, let's bring all of this together. Let's summarize the real-world impact of this release. At the end of the day, it's about empowering you to build better, more reliable software.
Now, what's really cool about this slide is just how clearly it shows the strategic shift. We're moving from older, implicit, and let's be honest, sometimes brittle methods to modern, explicit, and way safer abstractions across the entire board, from XML parsing to data conversion and all the way to error handling.
The core value proposition here is crystal clear. This release delivers a more robust, more modern, and fundamentally more reliable SDK. It's designed to give you the confidence to build and deploy those mission-critical applications that can actually withstand the rigors of real-world data and usage.
And here's the kicker. All of these powerful safety and correctness guarantees, they're delivered without a performance penalty. Thanks to those configurable safety policies, there is zero additional runtime costs in your production builds. You get safety during development and maximum speed in production. You really do get the best of both worlds.
So this release provides a powerful new foundation. It makes the SDK stronger, safer, and more resilient than it has ever been before. Which really leaves us with just one question. With a foundation this strong, what are you going to build next?